In the last video, we talked about regulatory limits for pollution and how difficult it is to decide how much or little should be allowed by law. The complexity of a single pollutant is enough to make this a difficult problem, but what about a mixture of pollutants? This brings us into the realm of mixture toxicology, a discipline that tries to understand an organism's response to a mixture of more than one biologically active chemical. The same discipline also studies consumer products such as alcohol. In mixture toxicology, there is a term, congener, that refers to an impurity or small amount of chemical in a mixture that gives it a distinct character. In alcoholic beverages, congeners might be small amounts of different alcohols like methanol or any number of plant-derived compounds and derivatives. Some of these congeners modulate the effects of ethanol, which is the drug alcohol. In this way, the different plants and processes that create unique beverages also cause their own unique physiological effects. Hangovers, for example, tend to be more severe with bourbon compared to vodka because of the much higher diversity and concentration of congeners in bourbon. The influence between components of mixtures can be described in one of four ways: synergistic, antagonistic, additive, or no influence. Synergy occurs when individual components have an effect on the system that is greater than the sum total of their individual effects. Antagonism is the opposite of synergy and causes a negative influence in the effect of each component. Lastly, additive interactions are an accumulation of individual effects. Interactions that are synergistic or antagonistic usually can be traced to a functional relationship between the modes of action. A mode of action is the chemical pathway by which a substance has an effect on an organism, but you can apply it at any scale. We are complex organisms, and we live in a complex world. This means that oftentimes the interactions in our bodies and in ecosystems themselves are functionally related and have a synergistic or antagonistic quality. This brings us back to pollution. Most of the time, organisms are not subjected to a single pollutant at a time. The rain that washes off roads is a cocktail of thousands of different compounds from drips of oil, greases, road salts, organic material, and metallic brake dust. These make their way into aquatic ecosystems and cause a combination of problems that are usually functionally related. The harm that pollution can cause to wildlife can be purely biochemical, or it could involve any number of mechanistic problems like decreased visibility causing lower successful hunts for predatory fish, or simply an abundance of trash and debris that clogs pathways for movement and can physically trap wildlife. When you stack these adversities on top of the toxic effects on physiology, pollution can have a greater negative impact on species or a habitat than would be expected when you think about each adversity individually. As it plays out, pollution of aquatic ecosystems causes a domino effect of failures in the system. This spreads up the food chain to birds and terrestrial animals, which go on to affect terrestrial ecosystems. The silver lining to this is that reducing or eliminating a pollutant will often have a greater positive effect than would be expected. These are known as nonlinear relationships, and science has come to understand these as the norm rather than the exception in complex systems. In medicine, these are a powerful tool known as dose-response curves. Rarely does a dose-response curve for a drug result in a linear relationship. Almost always they are nonlinear and take a variety of interesting shapes. It has been recognized that using linear models for regulatory limits will oftentimes underestimate the harm to people or wildlife at a given concentration. Toxicologists are working towards a holistic understanding of pollution where synergies and antagonisms within mixed pollution can be taken into account when determining the safety margins for drinking water and wildlife. Remember that littering can cause pollution that leads to a domino effect in aquatic ecosystems. But also remember that you can make an exponential difference by cleaning up a creek, lake, or river near you. Subscribe to see more stories on polluted properties.